Hello guys, it's Jenny Foreman here. This is assignment 8, Understanding and Clarifying Goals. And I'm a pre-cal and calculus teacher, and so I chose calculus for this week's assignment. Calculus does not have TEKS like the other courses do. Their standards come from College Board. And the way the College Board organizes their standards is very similar to the way our text Understanding by Design does. It talks about big ideas. In fact, in calculus, there's 3 big ideas, and those are limits, derivatives, and integrals. And so I consider that I have done a good job at the end of the year if my students are capable of not only knowing the basic skills of how to do, certain things, but if they understand the meaning of those 3 big ideas and how those 3 big ideas are connected. And so I'm constantly, having to use their prior knowledge of, what did this mean as a derivative, and how did we get that from the limit, and so on. I really like what the text had to say. They compared it to conceptual Velcro. They help the facts and skills stick together and stick in our minds. That's what they were talking about with the big ideas. They also say, I really liked this, it must enable the learner to make sense of what has come before, and most notably, be helpful in making new, unfamiliar ideas seem more familiar. And that's something that I'm constantly doing, is referring back to, in fact, we're doing integrals right now, and so I'm constantly referring back to, well, how did we get here? How are the integrals and the derivatives related to each other? Those are inverse operations. So anyway, you guys may or may not know what I'm talking about. But anyway, so for my established goals, I chose that students will use derivatives to describe the rate of change of one variable with respect to another variable, allowing the learner to understand change in a variety of contexts. And so my desired understanding is that the student will understand the derivative of a function is defined as a limit of a difference quotient and can be determined using a variety of strategies. I also included a graph here to kind of give you an idea of what that's talking about, since I know not many of you may be proficient with calculus. So I've got a function here. The red graph is my function, and we've got 2 different types of lines that have some points on that function. So that green line is the secant line, and then the purple line is the tangent line. Now, in their previous years of math, starting in Algebra 1, they learned how to find the slope of just any line. And so this is building on that. So they're having to use their prior knowledge. And so this idea of a derivative as a limit of a difference quotient, well, the difference quotient is that slope formula, the change in the rise over the run. That's the rate of change. And so what's happening here is, as this point that I've got my cursor on, as that horizontal distance gets smaller and smaller, and closer to 0, okay, closer and closer to this other point, notice that the slope of the green line is approaching the slope of the purple line. And so that's what this idea of slope, that limit is getting closer and closer to 0. That change in between those 2 points is getting closer and closer to 0, if that makes any sense at all. So my essential questions are, how can the derivative be represented graphically, numerically, analytically, and verbally? And so I showed a graph there, but you can also show it several different ways. How is the derivative related to what the student has learned in previous math courses? Well, that's what I talked about with the slope formula. What is the difference in average rate of change and instantaneous rate of change? So I'm going to look back at this again. So the average rate of change is the slope of the green line, which is what they knew how to do in previous math courses. Okay. The purple line is the instantaneous rate of change at a specific point. And so they're having to find the limit as that change in between those 2 points goes to 0. As it gets closer and closer, that average rate of change is approaching the instantaneous rate of change. Okay. So students will be able to identify the derivative of a function as the limit of a difference quotient. They will be able to evaluate the derivative of a function f as x of f at x as the limit as h, which is that horizontal change, approaches 0, of f of x plus, and that should say f of x plus h, excuse me, minus f of x over h, provided that it exists. They should also be able to use various notations for a derivative of y equals f of x, including dy dx, f prime of x, and y prime. And so that is what I chose for this week. Hopefully it made some sense to you guys. Here are the references I used, and I hope you guys have a great spring break.